Hello, fourth grade. We have another math mystery for you. This one is the case of the forgetful Pharaoh. Back in 1250 BC, you have found an ancient Egyptian scroll written by a royal scribe. Read it carefully. Ramesses, the great pharaoh, has been extremely busy focusing on building cities and monuments for Egypt. However, his hard work and dedication to making the country a better place has left the pharaoh frazzled, tired, and a little forgetful of late. Many civilians reported that the pharaoh appears to be missing his royal scepter, which is an emblem of kingship. It looks like a shepherd's hook and has alternating bands of blue and gold. A royal magician named Didi came to see the pharaoh early this morning. Their conversation was as follows. Didi the magician asked, "I have noticed lately that you have not been carrying your scepter. Why is that?" "Well, I've been so busy visiting many places lately, and with all that has been going on, I've forgotten where I left it," replied Ramesses. "I am frustrated, angry, and ever so tired. I've racked my brain trying to think where it could be. I was hoping someone would turn it in by now, but alas, still no scepter." Didi the magician suggested, "I know a spell that could summon a great detective from the future to come and help. Would you be interested in using them to locate your scepter?" Ramesses was surprised. "From the future? A great detective? Well, I must say I'd be most impressed if that were possible." Didi confidently replied, "You'd be amazed what a little magic can do. In fact, they are reading our very conversation right now." Didi continued to caution, "However, if the detective fails to complete this task, they will be stuck in our time forever." Ramesses' eyes filled with excitement and hope. "Yes, I would be most grateful for the futuristic detective, but you had better bring back more than one detective to guarantee they will find my royal scepter." Abracadabra, you have been teleported back to ancient Egypt. So now, in order to go back to the normal time period and get the pharaoh his scepter back, you need to solve some problems related to fractions. So as usual, you have your sheet with the possible places, and as you solve the clues, you're going to cross places off the list until only one remains. And that last place remaining is where Ramesses left his scepter. Let's look at some of these problems together. So the first one has to do with reducing fractions. And I'm going to have you go back and read all of the directions, but we're just going to practice one from each section together so that as you pause the video, read the directions, you can do it, but you'll see an example modeled for you as well. So you have to reduce each fraction as much as possible. Another word for reduce you might hear, it doesn't have to be, it could be reduce, or another word is to simplify. And we're going to do that using the power of the equivalent fractions rule, which says if we divide the numerator and denominator by the same number, you will get an equivalent fraction. Same works with multiplying the numerator and denominator by the same number. It's the same rule, but here, since we're getting it reduced or lower numbers, we're going to be using division. So let's take a look at this one together. I'm going to look at 3 and 12 and think, what could I divide both numbers by? Well, I know I can divide 12 by 3 and 3 by 3, and then I would get 1/4. Okay, and then I see that wherever 1/4 was, the letter P goes. Let's look at another one, 3/10. Is there a number that I could divide both by? Well, you can't divide 10. You could divide 10 by 2, but not 3. You can divide 3 by 3, but 10 you can't divide by 3 with it going in evenly. So this one actually is already as reduced as possible. So that one you just leave as 3/10. And then you know wherever there was 3/10, you'd place the letter A. Okay, so that's for reducing fractions. Next is going to be comparing fractions. And so you have a few strategies that you can use for this, but I want you to just glance through these fractions and let me know something or think about something you're noticing. I'm noticing that for a lot of them, they either have the same numerator or the same denominator. So whenever fractions have the same denominator, it's going to be pretty straightforward for you to decide which one's greater, right? 3/5 or 2/5, well, 3/5 is greater, right? You'd rather have three pieces of a cake that was cut into 5 pieces rather than just having 2 pieces of it. So 3/5 is greater. Now, this visual model can also help us think of with fractions with the same numerator, right? If you picture 1/12 in your head, picture a circle or whatever shape you want, cut into 12 equal pieces. See if I can do that quickly. But as you notice, these pieces are very tiny, right? 1/12 is a small little portion, whereas a whole of the same size cut into just 5 pieces, that's much bigger. So I tried my best to make them equal, not perfect. But so you can see, right, when they have the same numerator, the fraction with the smaller denominator will actually be the bigger fraction. And let's see, did it want us to circle the biggest? Circle the greater fraction. Yep, so 1/5. Good. And then that can help you go down and solve the puzzle below by looking at which one was greater, which one you circled. One other quick trick I want to show you, I'm looking down here at 2/6 and 8/12. Those don't have the same denominator or numerator yet, but again, we can use the power of the equivalent fractions rule. So 2/6, I could give that a denominator of 12 because I know 6 times 2 is 12. Whatever I multiply by in the denominator, I also multiply by in the numerator. 2 times 2 is 4. So this is 4/12 clearly. Now 8/12 is greater than 4/12. Last strategy, you could also compare to a benchmark, and we could do that on the same one. So 2/6, I know that that is bigger than a half or smaller than a half. Smaller than a half, right, because 3/6 would be exactly a half. And 8/12, bigger than a half or smaller than a half? I know that one's bigger than a half because 6/12 would be exactly 1/2. So that's another way to compare if this is bigger, and you can know right away that 8/12 was bigger. So quite a few strategies at your fingertips for comparing fractions. This next one looks at equivalent fractions with denominators that are multiples of 10. So you want to crack the code by writing the missing numerator or denominator to make the paired fraction equivalent. Use your completed equivalent fraction answer to match and place the letters in the box. So, we have to go down here first, right? And fill in the missing numerator and denominator. So again, you're using the power of the equivalent fractions rule, just with, it's even nicer this time because they're going to be multiples of 10. So I could see here to go from 6/10 to something in the hundredths. Well, 10 to 100 is times 10. So whatever I do in the denominator, I also have to do in the numerator in order to get my equivalent fraction. Okay, so you're going to go through and do those to get your letters. And then adding and subtracting fractions. One key piece in the directions, which I know you'll read very carefully, is that it does want you to reduce or simplify your answers. You're going to get stuck if you didn't reduce. Oh, good, and it even shows you that in the example. Okay, so remember when we're adding and subtracting fractions with the same denominator, you're basically just adding or subtracting the numerators and keeping the denominator the same. So let's practice with this one. 3/10 minus 1/10. Well, I know my answer is still going to be in tenths. And 3 minus 1 leaves me with 2/10. Am I done? No, I have to simplify it. And this time both could be divided by, if you said 2, you're correct. 10 divided by 2 brings me to 5, and 2 divided by 2, 1. So 2/10, same as 1/5, and that's going to help you fill in wherever you see a 1/5 to get your clue. And last one, converting improper fractions to mixed numbers. So remember that fractions are just division, really, right? So this is saying 14 divided by 3. And the inverse of division is multiplication. So I could think, how many times does 3 go into 14 without going over? Well, that's 4 times. And 4 would be the same as 12 divided by 3, right? So to get up to 14 divided by 3, I have how many left over? 2/3 left over. Okay, let's practice another one together. Let's go down to this one, 19/3. So I want you to ask yourself, you need to figure out the wholes first. So how many times could 3 go into 19 without going over? Pause if you need more time, but that would be 6 whole times. That brings us to 3 times 6 is 18, 18/3. But I want 19/3, so how many left over? 1 more third left over. So this will be some great practice for you converting to mixed numbers. And then once you're done, you've solved all the clues, you've crossed out on your sheet, then you are going to fill this out with the location of the Pharaoh's scepter, and your teacher will get back to you about how you've done and if you got to escape ancient Egypt or if you're stuck there. No, I'm just kidding. But we hope you enjoy your time travel and have fun with fractions.